Hey everyone, welcome. This is Jason Clemmons, Doctor of Chiropractic at the Rock Health and Wellness Center, and this is Life with Jason Clemmons, DC. We are live right here in the Rock Health and Wellness Center studios in this beautiful February 20th, Thursday. Hope you guys had a great day. We're live on 98.7 Walk by Faith and 1420 AM Lubbock Christian Nation, and we are bringing it to you tonight. So we're all over social media, and we're glad to be here. Hope you guys had a great day, and hope everything went your way. You guys that listened to the show last night, we got a little serious about stuff. We talked about, some viruses and how we handled it and all the things that we were, what's going on with us out there, right? And I've had some time to reflect on the show from last night, and I'm looking forward to continuing some of it tonight, talking to you a little bit more about it, and then just seeing if there's any questions that you have, any comments that you have about the show, anything that you might have learned from last night. You can send me a text, 806-794-0400. That's our text line. Or you can send us a message on Facebook or Instagram, not Instagram, YouTube or X. So we're in all of those places. Last night we got into viruses. I've been reading a bunch because we got this whole thing going on in Lubbock in West Texas about COVID, and I mean not COVID, about measles, and it's really stirred up a lot of people. And so I've been trying to share a little bit about that on our show, and it's kind of interesting when you talk about stuff like this because as I was driving today, as I was going to get adjusted, I was on my way to my chiropractor's office, and I was having a conversation with myself, and I just was kind of laughing, and I was like, when you do wellness chiropractic care, the majority of people don't care. I know that that's true, and I'm in the business, right? I'm not under any illusion that it's important to people. It's not important to most people. Wellness is not important to you until you're sick. And then when you're sick, you'll give everything you got to be well. It's just a funny thing how we do it. We don't care if we drink Cokes. We don't care if we eat sugar. We don't care if we don't get any exercise. We don't care if we stay up all night looking at our phone. We don't care about feeding our kids Pop-Tarts and all the rest of that stuff until all of a sudden we're sick, and it's like, hey, what do I need to do about this? And I know you guys that listen to the show on a consistent basis, you guys are in the minority. I can promise you, you're in the minority because you're already working on it before you get to that point. And good for you because it's not the normal thing, right? But we can't give up on the rest of the people. We have to at least give them some, we have to be there when they're ready. We have to be prepared. And then when they show up, we're say, okay, we've been working on this for quite some time, right? But last night's show was really, it was an accumulation of really 24 years of work and research and trying to figure things out that you can't necessarily talk about in society. Like we were talking this morning in the workout, and Debbie was talking, and she was saying, she was like, if I hear one more person say, I've never seen a single study that vaccinations might be related to autism. And it's like, yeah, exactly. Because you can't talk about it. I was rereading Judy Mikovits's book today, Ending Plague. And I was actually listening this morning. I was listening to her first book called Plague. And one of the things was she was giving a talk, and she said something about autism, and one of the people at the talk said, you cannot say anything about autism. You can't talk about autism in America. It's too much of a hot topic to talk about something like that. And I don't understand why. I don't understand why we just can't talk about it. I don't understand why we can't have a conversation about whether or not, about how our bodies work and what we're dealing with. And so, one of the things that came to me this weekend was this combination. I was reading Dr. Clemmons' book that was, I'll leave my bookmark right there, but The Case for Interferon. And he's a veterinarian and a highly recognized veterinarian. He lives in Amarillo, but um, he's a very decorated guy. Like, let me see. I got like a little bit of a bio that was put in here in Judy's book about that when she was talking about him, and yeah, she says this. She's in her book. She says, after the 2020 publication of our book, Plague of Corruption, I was contacted by a longtime veterinarian professor, Dr. Joseph Clemmons, who spent much of his career studying interferon in animals and humans. I learned Dr. Clemmons was a legendary figure in veterinary medicine and holder of 16 U.S. patents and author of 60 peer-reviewed scientific articles, as well as vital contributor to the field of HIV/AIDS research with leading scientists. Cummings did his undergraduate work at Ohio State University, served as a captain in the U.S. Army, and received his doctorate of microbiology from the University of Missouri. In 1999, Dr. Clemmons was named a distinguished alumnus of Ohio State University. He was in the very same department as Ohio State, where where my graduate school friend Kathy went to, a professor to start her career after her postdoctoral studies in the lab of Nobel laureate Howard Timmon, discoverer of reverse transcriptase. It says Clemmons had put together a book about his decades of work about interferon, and that's what I was reading. And that's how I got the book. Actually, is because whenever I'm reading a book like this, what I'll do is I was reading Ending Plague, and then she mentions in Ending Plague Dr. Clemmons' book of interferon, and I'm like, okay, and I just I immediately just go to Amazon. I get the book, I put it in the cart, and then I tell Leslie, hey, I got books in the cart, order it for me. We were laying in bed the other night. We were just about to go to sleep. And it was the last thing, I think it was the last thing I said besides I love you. Before I went to bed that night, I said, hey, I got 3 books in the cart right now. Would you order them right now? And she was like, yeah. And so, and I had another one come last night, Science for Sale or something like that. I can't remember exactly what that one was, but we got this one, and there's a couple more. We'll get to them eventually on the show here shortly. But so I wanted to know what he said. So it's basically 5 books in the last 3 weeks, 2 weeks, 2.5 now, that I've read over this subject, and from a standpoint of wellness, not from a standpoint of sickness. There's all kinds of people out there that study things from the standpoint of sickness. But I'm not interested in studying from the standpoint of sickness. For number one, I'm not a sick care doctor. I'm a healthcare doctor. And what I really have discovered, and for those of you who are listening to the show, I'm really serious about this. Like, if you could get this, you would be so advanced. I'm not saying I'm advanced. I'm just saying, like, compared to everyone else that you know, if you got this piece of information right here, you would be so advanced in the way that you operate as a human being on earth. And here's the piece of information. It's not necessarily the viruses and the bacteria and the fungus and all the rest of the stuff that's inside your body that is the problem. What is the problem is the way that your immune system reacts to it. It's the reaction part that's the problem. And I'll make a point about that in his book here. And he's talking about COVID. And he highlights this right here. And it said, it should be noted that COVID-19, as in many diseases, much of the damage seems to come from the body's inflammatory response. If you control the inflammation, you control the damage, especially to the organs. And I totally agree with that. That's what we talked about during COVID. It was like if we control the response to if we control our inflammatory response to the environment that we're in, we will have the because it's the one of my girls that just adjusted has a cold sore type of thing on the roof of her mouth. She's got pain up underneath her eye, and it's a sinus infection type of thing, and she's got a cold sore up underneath her mouth. And it's like, let me just share this with you. Antibiotics don't work on viruses. Just in case you're wondering, antibiotics are for bacteria. They're not for viruses. And herpes virus tends to make cold sores in our mouth. Okay? So if you get a sinus infection and it's viral, and your doctor goes and gives you an antibiotic, all you're doing is jacking up your immune system and your gut microbiome. And one of the things that he says in the book is like, if you don't even do a culture, in some countries, it's considered malpractice to give a person an antibiotic without doing some sort of culture to know if you're dealing with a bacteria, right? But what my point about this is that it's the cold sore that the body is creating the immune response to. It's the high fever that that's the body's immune response to. That's the all the autoimmune diseases that we have. It's about the body's immune response, and it's like it we don't. I don't think we understand that. I don't think we get it. I don't think we really understand it, to tell you the honest truth. This is just based on clinical daily conversations that I have with people day after day after day about just about the way that we function, right? So let's just say that we draw this graph, and you guys on the radio, you're going to have to just bear with us for a second. And I've drawn this graph before, but let's just say this is your symptom line. And you can name the symptom as anything you want to name the symptom as. You could say it's cancer. You could say it's Parkinson's. You could say it's Alzheimer's disease. You could say it's ALS or MS, or you can say it's stomach acid problems, or GERD or whatever. You could say it's eczema. You could say what you just pick it. You could say arthritis. You could say joint pain, right? You could say muscle stiffness. Whatever your symptom is. In chiropractic, we believe in the physical, chemical, and mental emotional stress. The toxins, trauma, and autosuggestion. That's the old timer guys. That's BJ and those guys from back in 1895. Toxins, trauma, and autosuggestion. In our office, especially for me, I've simplified it down to physical, chemical, and mental emotional stress. So let's add them up. Let's just add your physical, chemical, and mental emotional stresses, and all together. And you're like, well, I don't even understand what that means. What? Well, all right. Well, let's talk about it for just a second. Physical stress. The way you slept in bed last night, the way you sat at your chair today, if you sat at a chair and looked at a computer, or if you spent all day on your phone and you just had your head down all day, or you guys ever worked at a computer all day long where you're typing all like this and you get that burning right there at the base of your neck, where those muscles are just burning because your head's been forward and you've been typing for hours. Or if you're a farmer or a rancher or a construction worker or something like that, and you've had physical stress all day long, a car wreck, you lifted a refrigerator, and we get that, right? Like, everybody pretty much understands, for the most part. I think everybody gets it that, man, I hurt my back at the gym. I was lifting something and it hurt my back. Whatever. Okay, those are physical stresses, and we have a certain amount of adaptability. Let's just say the line at the bottom of the graph is, let's just say that this line down here is just perfect health. Like, if you're down here, this is absolutely perfect health. Well, you've got a certain distance from this line up here before, and that's what we call your ability to adapt, is that distance from there to there. Okay, so now let's just draw a graph simply talking about physical stress. And let's just say that, let's say we were cleaning the yard. You guys, spring's fixing to come around, and I promise you, people will come in here all jacked up from working. They got off work on Friday. They decided, hey, this weekend we're going to clean up the yard, and they're going to physically work all weekend long. They're going to work in the flower bed. They're going to scalp the grass. They're going to do all the stuff. They got to rake the leaves. They're going to do whatever your thing is, right? Trim the rose bushes and all the stuff. And by the time the day is over, you're just going to be physically stressed. Your muscles are going to be tired. Your feet are going to hurt. Your hands are going to be cramping because you've been doing stuff that you haven't been used to be doing. And you're going to have all this issue. You have closed the gap on your ability to adapt. Now, you can only handle so much more physical stress. Like you're just about to run out of ability to adapt. See how you've closed the gap? The more physical stress that you've had, the more you've closed the gap before now all of a sudden you're fixing to, if you go Sunday, like you worked all day Saturday in the yard, and then you're going to get up and then you're like, you know what, I don't have time to go to church. We're going to skip that and we're just going to work in the yard. And then you're going to get to the end of Sunday and you're going to take that last bag of trash and you're going to try to drag it to the dumpster because you put way too much stuff in it. And then when you get to the dumpster, you're going to try to lift it. And then all of a sudden, you're going to add more stress than your body is able to adapt to. And you're going to cross the symptom line and you're going to end up with back pain. It's like, ow. Oh man, I just did something to my back, right? I closed the gap on my ability to handle physical stress. Now let's switch it from physical to chemical. And it's like, what is chemical stress? Because we miss this. We do not understand what chemical stress is. And I watched a deal. I don't know what I was watching. I was watching something, and they were spraying DDT for all you old people. They were spraying DDT all over these people. Like these people were sitting out there, and the truck came by, and he just sprayed. I guess they were spraying for mosquitoes or whatever, and they just sprayed DDT all over somebody. Like, and the kids were riding their bikes in and out of the deal, and it was just like, oh yeah, DDT is not. There is nothing wrong with this. This is not toxic to the human body. Whatever. It's like, really? Like, what'd they find out? What's that thing that moms used to give their kids? I don't remember. Like when I was a little kid, and then I'll think of it in a second. But that you give them, and then all of a sudden, these kids started having birth defects and all kinds of problems because the mom took this drug way back in the day. Like Vioxx is a chemical stress. Like we know that sugar is a chemical stress. We know that artificial colors and sweeteners are not good for our body. We know that Roundup that we pour all over ourselves and all over our crops and all that sort of thing is toxic to us. And don't get offended if you're a farmer, because you know I love you, but we can do better, right? All of those things are chemicals. And so we've only got so much ability to adapt before we're fixing to have, if you go over the level of chemical stress, now what you're going to end up with is you're going to get a skin rash. Or you're going to have some other sort of neurological problem or something like that, right? Like you can't get chemicals on your body. And anything that's processed or come out of a box, like if I watched the other day how something was bologna, how bologna is made. Yeah, you should Google that. Like go to YouTube and watch how bologna is made. It's like, oh my gosh. So that's chemical stress. Those are chemicals we're not supposed to have in our body. And you can do the same exact thing with mental emotional stress. You can have One of my guys, last one of the day, came in, and I was like, "How you doing today?" And he's like, "It's just another day, just another day." And I'm like, "Come on, man! You're a person that gets adjusted at the Rock Health and Wellness Center. It's not just another day." Like, yeah, I said, "You got the Spirit of God working in you today. You're not. Come on, man. Recognize that." It's like, come on, and plus you're fixing to get adjusted. And by the time he got adjusted, he left, and he was so much happier. But you can only have so much mental stress. You get more mental stress, you get more mental stress, and then you just add that mental stress, and then what happens? Then you go over the edge, mental emotional stress, and now you get fussy. You erupt at your wife. You jump on your kids for something because you just stressed out to the hilt. You've had too much of it, right? Okay. Now just combine all these things together. Combine physical, chemical, and mental emotional stress together and add those up. And now what you've got is here's your ability to adapt to all the symptoms that are out there, all the problems that are out there. And let's just say for a second that what we're measuring in this particular thing is we're measuring your inflammatory response, your inflammation. We're measuring your inflammation. And if you increase your inflammation any more, then you're fixing to go over the top and you're going to get something. There's something that's going to happen. You're going to have some sort of response. If you close the gap where you no longer can adapt, you're going to get that symptom. And if we can understand, if we can understand this, that inflammation is the beginning of the immune response. What inflammation is chemical. It's not the Easter Bunny or Santa Claus. It's chemical. Inflammation has its chemistry in the body. It's chemistry in the body, right? It's not. And you've seen this 1,000 times now, right? This slide. It's taking corn and eating it, and your body turning linoleic acid into this DHGLA, this big long acid. Okay, that's what your body's going to do. What do you mean by that? What I mean by that is you're going to chew it up. You're going to get your saliva is going to get to it. It's going to go through stomach acid. It's going to separate all the parts, right? It's going to go through all that stuff together, and then let me see. Let me see if I can show this picture. See if this picture shows up. Yeah, that's glyphosate right there. That is an amino group with a carboxyl group on the end, and then some extra group on the other side of it right there. That's what it is. Now, don't get offended. I'm not talking personal about it. I'm just trying to show you when that gets into your body, this whole thing is not just going to go through your entire system just by itself. It's going to get broken up. Those bonds are going to get broken. You're going to get carbon and oxygen and nitrogen and hydrogen and phosphorus, whatever this is. You're going to get all this stuff is going to be broken up into different pieces inside the body. And then it's like, okay, what are those pieces going to do inside the body? And what they do is they create, in this particular thing that we're talking about inflammation. We're talking about this DHGLA is going to turn into arachidonic acid. If you have delta 5 desaturase, which means that you have this enzyme that only shows up, not only, but it shows up whenever you have insulin. And it's like, okay, well, why would I have insulin? Because my blood sugar went up. My blood sugar went up at the same time as I introduced corn chips into my bloodstream. And so I've got high linoleic acid and high amounts of blood sugar at the same time. And then what happens? This goes to arachidonic acid. And then here comes the COX enzymes, and the COX enzymes breaks that down to prostaglandin E2. It's the inflammatory part of this whole thing. It's inflammation. And so if we go and look at notes that I took from back in COVID, and I'm not talking about COVID, so people don't need to get fussy about that, but let me see where, yeah, let's see, there was one of them, PGD2, PGE2. Yeah, so we're just these notes that are right here, it's like we're talking about inflammatory responses that goes on. See if I can, let me switch the window right here. Yeah, so it's like PGD2 right here, DP1 signaling is required for upregulation of this inflazome inhibitor, which is interferon, basically, right here in the CD11B cells in the central nervous system in affected mice. It's like type 1 interferon signaling is required for this PYDC3 expression. I know all that stuff is just like speaking crazy, and it's like, but what I'm saying is that this is inflammatory response, and it's inflammatory response because it's activated by a virus. Inflammation is an immune response, and we got to take a break, but we come, just stick with me so we can just keep going through this, because if you really get this, then you'll understand how important it is to control your inflammation. It really is important. So stick around. We'll be right back. Let me blow this up a little bit while we're on the break. I got a bunch of these open, so yeah, so interleukin-1 beta activates B lymphocytes, increases inflammation, okay? We're talking about, what I wrote down is I was making notes about COVID, which is supposed to be a virus, right? So I was making notes. 1918, it started in Kansas in March and April. It came back hard in the winter of 1918, September, October, November. Why do viruses come back hard in the winter? What is it about the host that loses immune function in the winter? You know, here comes the cold weather, here comes November, here comes Thanksgiving, here comes Christmas cookies, here comes Christmas cooking, here comes rolls, here comes Thanksgiving, here comes all of this sugar, here comes pecan pies, here comes apple pies, here comes chocolate pies, here comes ice cream, here comes the winter, here comes the low vitamin D, and then all of a sudden we got this increased viral load in the winter. It's running rampant in America today, right? And what we get from it, what we get from this, and it's really what I'm trying to say is that this is immune response and it's inflammation. And we don't think about arthritis in our wrist. We don't think about arthritis in our knee or stiffness in our spine as an inflammatory response. That's what finally, it's like MS, AL. My grandmother died from ALS. My granddaddy died from Alzheimer's disease. My other granddaddy had heart disease and strokes and lost his foot at the end of his life because of the neuropathy in his foot. And my daddy would have wished he could have cut his foot off. Like he tried to get his foot, should have had his foot cut off. It was the most amazing pain in the history I've ever seen. Like from inflammation. My dad had ankylosing spondylitis, inflammation. And nobody ever really got me to understand that's immune system. Hang on one second. Let me get us back. Okay, everybody, we're back. This is Life with Jason Clemmons, DC. And we're talking about immune system function, and we're talking about inflammation in the immune system function. Okay, so that's what we're talking about tonight. And I really want us to get this understanding. I want us to understand that when you're having an inflammatory response, what you're having is an immune response. And the question is, why are you having an immune response? What is the immune response from? What is your body? Why is your body creating this? I mean, like, don't we get it? Don't we get that immunity is fighting off bacteria and viruses, pathogens from the environment? Don't we get that? Wouldn't everyone agree with that? Like, I think if you thought for a second and you're like, well, yeah, my immune system, I need a strong immune system, right? I need a strong immune system. I want my immunity to be good. I don't want to have a weak immune system. It's like, right, we want to have a strong immune system, but the first phase of that immune system, one of the very first phases of that immune system, is inflammation. And if we ever thought for a second that joint pain, arthritis, could be viral, if we thought for a second that Alzheimer's disease in our brain could be viral, could be bacterial, could be a fungus, right? That's what Dr. Brednison says in the end of Alzheimer's book. He says, look, there's a component of Alzheimer's that has to do with the viral response, or a fungus, or some sort of load from a pathogen of some sort. And we talk about sugar and the sugar chemistry that leads to inflammation. And we look at the sugar chemistry that leads to inflammation because of the fructose chemistry that leads to inflammation. And we just went over this last week, right? 2 weeks ago with Dr. Lustig's stuff of fructose metabolism. Fructose metabolism inside the body is going through all of this issue, increasing all these reactive oxygen species, which is free radicals, which is the reason that we eat our blueberries, which are our antioxidants, right? The reason that we're doing that, but look what happens. Inflammatory cytokines. That's what I said last night. It's the cytokine storm. It's the cytokine storm that is disrupting the way that our bodies are functioning. It's Hebrews 7 or whatever it was. It's remove the sin from the things that entangle us. That it's like, that means so much more to me this week than it did 2 weeks ago. The things I woke up this morning thinking about. I was a wide awake. My alarm wasn't supposed to go off till 5:13, and I was wide awake at 4 o'clock. Maybe I need more oxygen, but I just was thinking about the things that entangle us. We don't even understand. We don't even understand that scripture when it says the things that entangle us. We are tangled up. We are tangled up in inflammatory cytokines from sugar. We're tangled up in inflammatory cytokines from this increased reactive oxygen species, from fructose. It's like, and then what happens? We get inflammatory cytokines. We get an increased amount of inflammation, and we close the gap on our graph over here. We're just driving this inflammation up, and we're driving this inflammation up. We're driving this inflammation up. And then all of a sudden, it's just like, here goes, like this overreactive response of our Th2 response. We got this adapted immunity that just gets like, whoa, like goes crazy. And then and what are we doing? Or something sets off one of these retroviruses. And I wanted to say this tonight because I just want to make sure. Oops, sorry. I got to figure out this whole this microphone thing, but what I just read about Dr. Clemmons, right? He was in the same department at Ohio State where my graduate school friend, Kathy, went as a professor to start her career after her postdoctoral studies in the lab of Nobel laureate Howard Timmon, I can't say that right, Temin, discoverer of reverse transcriptase. Okay, this is the same school that Dr. Clemmons went to. Reverse transcriptase. What does that mean? And what does it mean to have a retrovirus? You have a cell. Inside the cell, you have a nucleus. Inside the nucleus, you have the double helix of the DNA, right? We all know that. That's way back from the old days of school. Oh, shoot, you're not even seeing all this. Whenever your body wants to express itself, whenever your body, remember the word epigenetics that we talked about? Epigenetics, the environment upon the genetics, right? I'm going to have some sort of environment upon the genetics. Since we're talking about glyphosate, let's talk about it, right? Let's talk about Roundup. The Roundup gets to the cell. It hits the cell. The cell now transfers that information to the nucleus of the wall of the nucleus. Now that transfers into the middle of the nucleus, and now we have to look on the DNA and try to figure out how we're going to respond to this chemical stress. So we're going to have to unwind a piece of that DNA. We're going to have to figure out which part of it we're going to copy. Let's say we're going to copy that. And then we're going to unwind it and we're going to copy it. And when we throw it out into the cytoplasm, what we're going to have is RNA. And that's going to be what we're going to copy, that RNA, so that we can make proteins, so that we can put them outside of the cell. And this is the way we are going to respond. Okay? That's a very simple way of the way that it's not our genetics, it's our epigenetics upon the genetics, right? That causes us to express ourselves. It's easier if we don't use Roundup. It's easier if we use heat. Because everybody knows if you get really hot, the way you respond is to sweat, right? But it didn't just go from heat to sweat. It went through the process of expression into the body to be able to change the way that our sweat glands released heat and all this sort of thing. Like there was a process there, right? Okay. An XMRV or HIV or HTLV, I think it's what it is. I think this was the first one. And sometimes I get those messed up, but that was the first one that they found. Then they figured out HIV was a retrovirus. Then they figured out XMRV was a retrovirus. It was somehow we picked up this virus from an animal. We picked up a piece of RNA. And so the reason it's called a retrovirus, instead of it coming out the normal direction, it's going backwards. It's coming into, this is now getting put into the cell, and this is now getting put back into the nucleus, and what's trying to happen is that might get sewn into your DNA, and now that RNA from that animal becomes part of your DNA. So now it's like, whoa, and how does this happen? Reverse transcriptase. Reverse transcriptase. Transcriptase. If you do a blood test and you have an increased amount of reverse transcriptase, then you have a retrovirus. That's how they detect it. That's how they detect whether or not you're dealing with the retroviruses, because you got increased reverse transcriptase. Okay, it's sewing the RNA back into your DNA. Now, here's what happens. Now, whatever our environmental epigenetics is, our environmental epigenetics now goes through, and we accidentally, for whatever reason, we go in there and we copy a part of our DNA to deal with our environment, and we end up copying this RNA that was, or some little slip of it, or some little part of it, we end up copying that RNA that was part of that had been sewn into our genetic code through reverse transcriptase, and it's sewn into our genetic code, but the environment has it now released, and we release this RNA from a mouse or a animal of something of whatever it is, and our immune system attacks that. And a lot of times what you'll call that is autoimmune disease. And sometimes this will happen. We have interferon in the cell. Interferon is inside the cytosol of the cell, inside the middle of the cell. And interferon will attack from the inside of the cell. Go to Google Scholar and you just look it up. That's what I did at lunch. See if I can find out which one of these I read. I got it somewhere. I thought I was going to leave it. Open, but I guess I didn't. But I was reading about interferon. Sorry about that. I thought I had it open. But this interferon will show up. It will appear. It will respond to cytosolic DNA. If there's any sort of DNA that gets in here that somehow got copied, or it's going to try to kill it, and it's called it's like apoptosis, programmed cell death, but it's pyroptosis, whatever it is. It's just a different form of apoptosis. It's going to say, nope, killing that dude right there. Like interferon steps in and says, no, this cell's done. We're not doing any more of that. But what happens if we miss it? Or what happens if our immune system sees that thing from the inside? We'll end up getting some sort of autoimmune disease, right? And now it's like, what are those autoimmune diseases that are going on inside the body? There's a bunch of them. Idiopathic pulmonary fibrosis, a chronic inflammatory fibrotic disease of the lower respiratory tract. Gastrointestinal inflammation. Beck's disease is a severe, rare, chronic, relapsing autoimmune disease characterized by oral and genital ulcers, eye inflammation, and skin lesions, as well as joint, blood vessel, and central nervous system gastrointestinal tract inflammation. That's my point right there. That's a great example. This autoimmune disease results in oral and genital ulcers, eye inflammation, skin lesions, joint, blood vessels, central nervous system. Okay? All of these symptoms that you and I call some sort of disease is this immune response that's going on, that's happening. Here's another one. Dr. Greenspan, professor of UFC San Francisco, treated oral complications of HIV patients for 30 years. He is considered Dr. Greenspan is considered the grand dam of HIV-positive stomatology, of the world's expert on oral warts. HIV patient gets warts in their mouth. They treated them with interferon and controlled them. Clinical trials in fibromyalgia was conducted in March of 2000. Again, interferon to treat fibromyalgia. You see what I'm saying? Like you've been told your whole entire life that autoimmune disease is the immune system making a mistake and attacking itself. That's not true. The immune system doesn't make a mistake and attack itself. The immune system is attacking something that's in there that's not supposed to be in there. I don't believe for 1 second that the immunity that God gave us is making a mistake and attacking itself. And if you don't believe in God, I don't believe that 30 million years of evolution is going to say that either. I think that what's happening is autoimmune, Hashimoto's disease, whatever. You want to go to the thyroid, you want to go to the adrenal glands, you want to go to my dad with ankylosing spondylitis, You want to go to MS or ALS with my grandma? You want to go to Alzheimer's disease or Parkinson's? No, there's something that's causing the body to respond that way. It's just, there's no question in my mind that is that's a true statement. Hepatitis B infections, like it just, there's so many of these things that you can look at. And here's something that I highlighted. The data showing XMRVs blocked production of type 1 interferon from plasmacytoid dendritic cells, suggesting low-dose interferon could stop transmission of retroviruses. Yeah, if we could give them some interferon, we could stop those retroviruses. This guy, Dr. Buddy Brandt, was he was a veterinarian himself. He had undergone surgery in November of 1983 and required multiple blood transfusions. In February 1986, he was diagnosed with AIDS-related complex. Now, AIDS-related complex is the result of HIV, and HIV is a retrovirus. So how did he get the retrovirus? He got the retrovirus from the blood transfusion. He got, just like Arthur Ashe got the blood transfusion, and just like Ryan White got AIDS from a blood transfusion. Where did the retrovirus come from in the blood? It came from another person. Somebody went to the blood bank and gave blood, and then Dr. Brandt had surgery, and then ended up with AIDS. And look at all the stuff that he was dealing with. He was admitted to the hospital with pneumonia. This may have been his first AIDS-related illness. Subsequently, herpes, genital warts, diarrhea, herpes simplex mouth ulcers, respiratory infections, weight loss became chronic, and in February, AIDS-related complex was diagnosed. Our patient was a veterinary surgeon. Success with oral human interferon alpha in feline leukemia and his chronic weight loss and depressed T4 lymphocyte counts prompted him to experiment with interferon alpha in the human form. Self-treatment was followed by a rise in T4 lymphocytes counts from 153 to 319, regression of genital warts, improved appetite, and weight gain. And then what he did is he called Dr. Clemmons and he got some, and he asked him about, hey, how would you treat a big dog with interferon? And Dr. Clemmons didn't know that all this stuff was going on with Dr. Brandt. And so Dr. Clemmons told him about treating this dog with interferon, and then he treated himself. He wasn't treating the dog. He was treating himself. And he treated himself with this, and he started getting better from AIDS. But my point that I keep wanting to make here is that he had pneumonia. He had respiratory infections. He had mouth ulcers and genital warts and diarrhea and all these things. All of these symptoms, that immune response, and it was this constant overreactive bombardment of the immune response trying to get rid of that retrovirus, or the retrovirus stimulated the immune response. I'm not exactly sure what exactly is happening right there. Nobody else really is either. But then what happened is the interferon treatment was discussed with his physician, who discouraged its use, and the treatment was discontinued. His T4 lymphocyte count decreased within 6 weeks to 146. His physician prescribed ribavirin for the next 8 months, and during ribavirin treatment, however you say that, the patient experienced weight loss and anorexia. His T4 counts varied from 146 to 218, and in January 1987, his condition deteriorated from ARC to AIDS, according to his primary physician. At the end of 1987, he began a course of low-dose units of oral human interferon, and over the past 11 months, his appetite returned, he gained his weight, his herpes simplex and mouth ulcers have disappeared, the genital warts have regressed and recurred, and T4 counts have risen from 210 to 520. He feels better than he has for 3 years and has been able to maintain the quality of life that he has it for the last 11 months. And then he wrote the letter to Lancet. That's where he was writing this letter. It was to tell him what was going on. When he decided to use the interferon, his body got healthier. His body got healthier. And then he went to the doctor, and the doctor said, you can't use that. That's not acceptable. You need to use this prescription medication that we have. And then he got sicker. And that's what is like, no, it's so hard to talk about that. It's so hard to talk about that because that's what I was trying to talk about last night. That the health department says the best way to avoid the disease of measles is to get vaccinated. Okay, that's their stance, but I don't know if it's the best way. It may be a way, but if you end up with MS or ALS or chronic fatigue syndrome or prostate cancer or lifetime of asthma or allergies or ADHD or autism or any of those other things that might be related to it, then it doesn't necessarily seem to me that that's the best way. I think the best way is to be healthy. I think the best way is to control your inflammation. I think the best way is to understand that when you drink apple juice, you're going to end up with inflammatory cytokines from your liver. I think the best way to understand that the Bluebell ice cream that you're about to eat for supper, or the refined carbohydrate that's in the spaghetti, or the rice that you're going to get down at Chipotle is full of carbohydrates, which is going to increase your blood sugar, which is going to decrease your immune system. That's the thing we ought to be focused on if we're interested in being focused on it. And most people aren't. But you are. You've been sitting through this thing for an hour now, 40 minutes. Shoot, we're almost done. If you sat through it this long, I guarantee you that you're interested in health. And that's why I'm doing the show. I'm doing the show for the individual people that are listening to the show. That maybe you can take some of this information and you can make your life better by understanding the physiology that's going on in the body that's causing us to be over-responsive to this thing. It's like, how do we get our inflammation down? How do we get our inflammation down? How do we get this to stop? Take an NSAID? No. It's toxic to your liver. It's toxic to your kidneys. Like, no, we got to decrease this inflammatory response. Degenerative joint disease. One of my ladies asked me today, why is my spine deteriorating? I'm like, you've got inflammation out the wazoo. Like why did my dad's spine, bamboo spine? Why did it looks like a bamboo all the way from top to bottom. He had no motion from his tailbone to his neck. Zero motion. Do we understand how important motion is? Like, we're not talking about neurology tonight. We're not talking about movement is life, right? What we're talking about is inflammation, immune system dysfunction inflammation, heart disease, free radical, pain, scar tissue. We're talking about inflammation. And how do we get that inflammation to be down? Number one is we control it with our diet. And we could go back through the Spark book. And I guarantee you, if I got the Spark book by John Ratty, and I said, hey, I bet you we could find in there. That's what I was thinking about this morning when I was watching the 80-year-old, the 81-year-old, and the 70-year-olds work out. And they were kind of going slow. And I said, come on, move it. No, I'm not going to. Am I going to baby them? Absolutely not. Why? Because I know that exercise is making them healthier. They're 80 years old and they're getting healthier. 81, 82, something. He's getting healthier. He's able to move at 80 years old better than he did when he was 79 years old. And he's decreasing his inflammation with his exercise. We decrease our inflammation with our diet. We get into those whole foods that we talk about. We eat those grass-fed animals, not those corn-fed animals. See what happens when you eat a corn-fed animal? You increase arachidonic acid. Now, the arachidonic acid is part of what's inside of you, but you don't have to increase it. Another thing right here, you see what this says? COX enzymes upregulated with every antibiotic. Every time you have an antibiotic, you upregulate your COX enzymes. So we went to the doctor with a sinus infection that was most likely viral. I don't know. We didn't check it. We didn't check to see. And then we took an antibiotic, and what did we do? We upregulated our COX enzymes. And when we upregulated our COX enzymes, what happened? We regulated our arachidonic acid to prostaglandins. We increased our inflammation. What happens when we get a flu shot? We increase our inflammation. What happens when we get a COVID shot? We increase our inflammation. To me, it's like, calm this bad boy down. Let's get this inflammation controlled. What do? We take our omega-3 fatty acids to get our inflammation to come down. It's life-changing if you get it. If you really get it, I think this information is life-changing. And I hope you got it tonight, because we're out of time. So if you got any questions, comments, you want to send me something, you want to just send me a thing and say, Jason, you suck, whatever, I don't care. Any of that stuff would be great. But I hope you got it, and I hope tonight helps you live a better life. And I'll be back tomorrow night at 6, and we'll do it all again. So thanks. You guys have a great night.